welcome to this video. So today we'll be solving another LeetCode problem called search insert position. Okay, so this is a easy problem and let's read the problem statement. So according to the problem, we have been given a sorted array of distinct integers and a target value, and what we have to do is that we have to return the index if the target is present in our array, which is a sorted array, and if it is not present, then we basically return the index where it would be if it were inserted in order. Okay, so what does that mean? So basically the question is asking us to do two things here. First, it is asking us to search that target value in that array. Okay, and if the value is present, then we return its index, and if it is not present, then it is asking us to find the index at which the target value should be inserted so that the given array still remains sorted. Okay, so let's look at a few examples here to develop our understanding. Okay, so suppose that this is the value of nums and this is the target. Okay, now we know that target, which is equal to 5, is present in nums and it is present at index 2, so we return 2 in this case. In example number 2, this is the value of nums and this is our target 2. Okay, now we know that 2 is not present in nums, but if I inserted this value 2 in nums at index 1, which is basically after before this 3, so the array would have become 1 2 3 5 6, which would have been in sorted order, hence the answer is 1. Okay, similarly for example 3, here the target value is 7. Now 7 is not present in nums, but if I inserted it at index 4, which is after this 6, then nums would still be ordered. Okay, so this is what basically this question is asking us to do. Okay, so let's look at an example here for more understanding. Okay, suppose that this is our nums array that has been provided to us, and the target that we are looking to find is say for 2. Okay, now we have to do either of the two things: check if target is present in nums or not, and if it is not present, we have to find the index at which target should be inserted so that the nums array is still sorted, right? Okay, so let's see how we can do it. This is one of the approaches. So one approach is basically we start at index 0 and keep traversing this array to search the value of to search if the target is present in nums or not. Okay, but the question is, like, should we just keep going over this array blindly, or like is there a condition that we can stop before and still get our answer? So let's see. Okay, now suppose that we start at index 0 and keep comparing the values at every index with our target. Okay, so this will eventually lead us to index 5. Okay, so now what is special about this value 3? Okay, the special thing or unique thing about this value 3 is, like, all the values that we had seen previously, they were less than our target. Okay, and this is the first value that is greater than our target. This is the first value that is greater than or equal to our target, we can say. Okay, now since this value 3 is greater than our target in this case, so we definitely know that our target cannot lie to the right side of this value because this array is sorted. So all the values which are on the right side of 3 are already greater than or equal to 3, and the left side, it also doesn't contain our target because we have already searched for it. So 3 is the first value which is greater than or equal to our target. So in this case, we can simply return the index of 3, which is 5. Okay, because this value is the smallest value which is greater than our target, right? So if 2 were to be inserted in this array, it should have been inserted at this position between 1 and 3. okay, so that the array still remains sorted. So basically the crux of this question is that either we find the value, target value in nums, or we return the index of the value of the smallest value which is just greater than our target. Okay, so if I were to write a quick code for this problem, or so it would look something like this. So for I in range n, if nums I is greater than or equal to target, then we simply return I. Okay, and say for we reach the end of the array and we still haven't found uh, that the target, or you can say like all the values are already less than our target. Basically in that case, suppose there is a value 19. Okay, so this if condition would never be met. Okay, because we will go back, we'll go to the end of the array. Okay, so in that case we simply return n, because the value should be inserted at the end of the array. So we can in that case, like, we can simply return n. Okay, talking about the time complexity, so we know that, like, in worst case we might end up traversing the entire array, so the time complexity of this solution would be big O of n. A solution from our previous approach, which is big O of n solution. Okay, but let's see if we can try to do any better here. Okay, so it has already been mentioned to us that the given array is sorted. Okay, so whenever the input is sorted, we should always try to check if we can solve the problem using binary search, because binary search operates on sorted inputs and it provides us extremely efficient runtime. So we should see if we can solve this problem using binary search. Okay, so like as in the previous example as well, we'll assume that the target value that has been given to us is 2. Okay, so now for binary search, let's define the search space, which is the low and high pointers. Okay, so we'll assume that like the entire array is our search space. Okay, so let's note down the value of low and high. Okay, okay, so starting with binary search, we reach a mid of 3. Okay, so basically now the mid pointer points to index 3 and the value is 0. Okay, now we know that 0 is less than 2, so what we would do is that we would shift our low to the right of mid by 1 and we will discard this entire space. Okay, so now what would happen is that low will now start pointing at index 4. Okay, and now the new value of low is 4, h is equal to 7, and then if we calculate mid, it would be equal to 5. Okay, so now this is where the mid will now point. Okay, now this value is greater than our target value, so high will now shift to the left of mid by 1. Okay, so I'll remove the previous values and now these will be the new values. Okay, so let's write the values of high and low for this iteration. So L is equal to H is equal to 4. Okay, now if we calculate mid, then that will also be equal to 4. Now we see that the value at index 4, which is 1, is less than our target value. So what would happen in this case, that the low will now shift to the right of mid by 1. This is where our new low will go. Okay, now low will become equal to 5 and h is equal to 4. So what would happen is that our binary search will now terminate as our low is greater than high. Now let's try to observe that in case if a binary search is not able to find a value, then where does low and high point at the end? Okay, so this is actually high, sorry. Yeah, so let's try to observe where does low and high point in case if binary search is not able to find a target value in a sorted array. So here you can see that low is pointing to value 3, which is the smallest value which is greater than our target of 2, right? And high is pointing to value 1, which is the largest value that is less than our target 2. Okay, so this is a very important point in binary search. Okay, that say for if binary search is not able to find a value in value, okay, so low basically points to the smallest value that is greater than our target value, and high points to the largest value which is smaller than our target value. Okay, this is a very important point. So suppose that if we had been searching for say for -11, okay, in this array, so when binary search terminates, so the value of high would have been -1 and low would have been 0. So in this case low is pointing to the smallest value which is greater than our target value -11, which is -10. Okay, and had say for if the target value say for had been 21. Okay, so if you run binary search through it, then you would notice that in this case low, the final value of low is 8 and the final value of high is 7. Okay, so again high is pointing to the largest value which is less than our target value. Okay, so with this observation in mind, so all we need to do is that we need to return the value of low from this binary search operation, because low is already pointing to the smallest value which is just greater than our target value, and this is what we were trying to do in approach 1 as well. Okay, so if we report this low index, so here so basically that would mean that we want to insert the value 2 at index 5, which is before, which is between these 1 and 3. Okay, so let's try to code up this solution. Okay, so suppose that low is equal to 0 and high is equal to length of nums -1. So like these are this is the search space of our binary solution, and now we use the condition while low is less than equal to high. Okay, we go to the mid of the search space, and then we basically check if the value at this index is equal to our target value of not. If it is equal, then we simply return mid. Okay, if this value is less than our target value, then what we do is that we shift the low to the right of mid by 1. Okay, else we move the high pointer to the left of mid by 1. Okay, and then at the end, if we are not able to successfully locate this target in nums, then we simply return the low index which at the end of this search would be pointing to the index whose value is just greater than our target value. Okay, so let's try to run this code. As you can see, like, this code is accepted. Okay, so talking about the time complexity of this code, as you can see, like, this is a standard binary search code and we haven't added any special condition, so the time complexity would be big O of log n. Okay, so like, this is a very important question in the sense, like, it helps us, it basically shows us where the low and high pointers of the binary search point in case of an unsuccessful search. Okay, so this concept is used in many other problems as well, so it's important that we look at this problem in more depth and more detail. Thank you.